China's infrastructure black technology builds an 11-story building in 28 hours. It is not afraid of magnitude 9 earthquakes.
China has proven to be the nation widely known for mind-blowing constructions. However, this time around, even the Chinese president couldn't believe his eyes when he saw this genius construction technique. Across the world, from the US to Europe, builders and engineers are pushing boundaries with incredible techniques that almost seem to defy physics. From 3D printed houses, windows that grow algae for natural heating, or even concrete that can heal its own cracks. These innovations are changing the game. Join us in this video as we unveil these masterpiece discoveries. Italy's technique of building bricks from literal thin air. A clever idea developed by Italy's Dante Bini, this technique is called the inflatable concrete technique. Imagine constructing a building using air. Here's how it works. First, workers lay out an inflatable canvas shaped like a dome or whatever design they want. They fill it with air, which forms the basic outline of the structure. Next, steel bars are arranged over the inflated dome to create a sturdy grid. Once that's in place, concrete is poured over the surface. After the concrete hardens, the air-filled layer inside is removed, leaving behind a strong, freestanding structure. The best part? The same inflatable mold can be reused multiple times. This makes it a fast, efficient, and cost-effective way to build shelters, especially for emergencies or temporary housing. Italy isn't even done yet. It has yet another mind-blowing innovation called the bridge launching. This method, designed by Italy's Marco Rosanoli, now ranks as one of the coolest ways to build a bridge. Here's how it works. The bridge sections are pre-built in a factory with exact precision. Once transported to the site, they're assembled, not over the river or valley itself, but on a nearby piece of land. From there, the entire bridge is carefully pushed or launched into its final position. It's a stunning display of precision engineering, and a reminder that creativity in construction truly knows no borders. Next comes the fascinating part, the launching nose. This long metal framework made of girders is attached to the front of the bridge span. Its job? To guide and support the bridge as it slides into position. Then, the real magic begins. Giant machines, each weighing several tons, lift the entire bridge structure. Once raised, it's placed on special bearings coated with low-friction materials. This setup allows the bridge to glide forward smoothly without bending or breaking under pressure. Using hydraulic jacks and precision-controlled equipment, engineers slowly push the bridge forward, inch by inch, until it slides perfectly into place. Watching such a massive structure move gracefully through the air is nothing short of mesmerizing. Once the bridge is fully aligned, the temporary framework is removed, and the structure is locked down securely. Installation complete. For smaller bridges, this entire process can happen in one go, but for larger spans, engineers take an incremental approach. They push one section forward while adding new segments at the back, repeating this cycle until the entire bridge is complete. It's an incredibly delicate process. Every move must be perfectly timed and measured. One mistake or slight misalignment could ruin the entire structure. Still, when done right, this method saves an enormous amount of time. What would normally take weeks can now be done in just a few days. Are there more nations with this amazing innovative engineering techniques? Keep watching to find out. The most heat-resistant material on Earth, America's aerogel insulation. Aerogel is unlike anything else on Earth. Developed in the United States, it's often called frozen smoke because of how light and translucent it looks. But don't be fooled by its airy appearance. This material is one of the best insulators known to science. How good, exactly? Picture this. You can hold a thin sheet of aerogel over an open flame, and it won't even melt a piece of chocolate resting on top. That's how effective it is at blocking heat. NASA uses aerogel to protect spacecraft and astronauts from the extreme temperatures of space, and now this once space-exclusive material is finding its way into everyday buildings. In construction, aerogel panels are being used to insulate homes, keeping interiors warm in winter, cool in summer, and quiet all year round. It's so lightweight you can barely feel it in your hand, yet its performance is unmatched. It also doubles as a noise-cancelling layer, reducing sound pollution and creating more peaceful indoor spaces. Aerogel might just be the future of sustainable living, proof that the line between space technology and everyday life is getting thinner by the day. But the surprises don't stop there. Because aerogel is so efficient, you only need a very thin layer of it to get the same insulation you'd normally need several inches of other materials for. That means more usable space inside a building, thinner walls, bigger rooms, and smarter design overall. It's compact, powerful, and incredibly effective. The kind of innovation that makes you rethink what's possible in construction. What other genius construction is out there? What nation is creating the next mind-blowing structure? Keep watching to find out. America's slip-form construction. Developed by American architect James McDonald, this technique completely changes how tall structures are built. The process starts with a formwork, basically a mold that defines the shape of the structure. Once that's set up, concrete is poured into it continuously, while the formwork itself slowly climbs upward. As the concrete hardens, it creates a stable base that supports the next layer above it. The formwork keeps crawling higher, like a machine building its own tower as it goes. It's fast. Sometimes a building can rise several stories in just a matter of hours or days. However, this method isn't without its limits. Because the mold moves continuously, it can't be easily changed mid-construction. That means slip forming is best suited for structures with repetitive layouts, like silos, towers, and chimneys. To work around that limitation, engineers developed a similar technique known as climbing formwork. Instead of pouring concrete non-stop, builders complete one level at a time. Once a section hardens, the formwork moves up to the next floor. This approach offers more flexibility. It allows for more complex floor plans, greater precision, and better control during the build. It may be a bit slower than slip forming, but it's still one of the most efficient ways to create skyscrapers quickly, cleanly, and with minimal noise or waste. In both slip form and climbing form work, the framework doesn't rise on its own. It's powered by hydraulics. Multiple hydraulic arms push the formwork upward in perfect coordination, moving like the legs of a caterpillar crawling up a wall. It's a fascinating sight, a structure literally growing taller before your eyes. A bold American innovation that completely challenges how we think about building. Traditionally, construction starts from the bottom. You dig down to build the basements and foundations first, then move upward from there. But with top-down construction, engineers do both at the same time. Here's how it works. Builders begin by constructing the above-ground floors, while excavation teams simultaneously dig below. As the skyscraper rises into the sky, the basement levels expand downward, floor by floor, layer by layer. So how does the whole thing stay supported during this complex dance of upward and downward building? It's all in the sequence. Each newly completed basement slab acts as a brace, supporting the retaining walls and redistributing the structure's load. With every level dug and completed, the foundation gets stronger. This process continues until the full structure, both above and below ground, is complete. Top-down construction has quickly become a favorite in crowded urban environments, and for good reason. It saves a huge amount of time since work happens in two directions at once. Plus, it causes far less soil movement, a major advantage in cities where space is tight and disruptions can cause big headaches. Does anything come close or even rival this level of mastery? Keep watching to find out. Germany's light-emitting concrete. Now, from towering concrete structures to something that actually glows, let's talk about light-emitting concrete, one of the most beautiful and practical construction technologies emerging today. Developed by researchers in Germany and Hungary, this innovative material contains phosphorescent properties, meaning it can absorb light during the day and release it at night. The result? A gentle, natural glow that can illuminate surroundings without the need for electricity. Imagine roads that light themselves after dark, making driving safer while saving energy. That's exactly what experts hope to achieve with this new technology. But the possibilities don't end there. In Abu Dhabi, the stunning Al-Aziz Mosque uses a similar idea. Hidden lights behind the Arabic calligraphy illuminate the walls at night, turning the sacred texts into a radiant, glowing masterpiece. Once perfected, light-emitting concrete could transform the way we design our homes, streets, and cities, blending function with pure visual poetry. Isn't this the future already? Or what else does the future hold? Keep watching to find out. Germany's algae facades. And speaking of turning nature into power, Germany is taking things to a whole new level with a living, breathing innovation, algae facades. Construction companies like Solar Leaf are experimenting with building facades that literally grow algae inside them. The Solar Leaf system is the world's first fully functional bioreactor facade, created through a collaboration led by the Berlin branch of engineering consultancy Arup. Completed in 2013, this groundbreaking project made waves in the design world, beating out 355 other contenders to win the Applied Innovations category at the Zumtobel Group Award 2014. Hosted by the global architectural lighting company. Germany is moving toward a future of zero-energy homes, with a regulation set from 2020 requiring every new building to generate as much energy as it consumes. The Solar Leaf project was designed to tap into the natural energy storage potential of biomass, providing a solar-powered heat source without relying on traditional batteries. Partially funded by the German government's Zukunftsbau, translated as Future Building Research Initiative, the project brought together several industry leaders: Arup, the biotechnology and microalgae specialists, Strategic Science Consult, and Colt International, experts in integrated climate control, ventilation, and solar shading systems. Here's how it works. Small colonies of algae are placed between glass panels filled with water and a bit of carbon dioxide. With sunlight, the algae grow rapidly, and that's where the magic happens. One of the first examples of this technology in action is the Biointelligent Quotient (BIQ House) in Hamburg, Germany. One of the biggest advantages of using microalgae is their incredibly simple unicellular structure, which allows them to produce biomass at a much faster rate than most plants. In larger plants, not every cell participates in photosynthesis, but with microalgae, every single cell is fully engaged in converting light into chemical energy. As a result, they can grow up to 10 times faster than traditional plants. The 200 square meter facade system is installed as a secondary layer on the southwest and southeast sides of the building. It's made up of clusters of 3 to 5 transparent glass panels, each about 2.5 meters tall and 0.7 meters wide. These panels, known as flat panel photobioreactors (PBRS), contain water and nutrients that circulate continuously. Inside, the microalgae absorbs sunlight and carbon dioxide, generating both biomass and heat energy as natural byproducts. How crazy is the next innovation? Keep watching to find out. Switzerland's 3D knitted formwork. Developed by ETH Zurich in Switzerland, this cutting-edge technique allows architects to create complex, curved concrete structures that would be nearly impossible with traditional molds. Here's how it works. An industrial knitting machine produces a double-layered textile, perfectly tailored to the dimensions of the structure. The flexible fabric is then stretched into shape using ropes and a boundary frame, and just like that, the mold is ready. Once the form is in place, a thin layer of concrete is sprayed onto the outer surface, thick enough to provide strength, but light enough to maintain flexibility. The result? Beautiful organic shapes that look as though they were sculpted by nature itself. Once the concrete dries, the 3D knitted structure is complete. No bricks, no cement blocks, no heavy molds. The boundary frame and support ropes are removed, and the structure stands tall on its own. And it's not just about looks, it's impressively strong too. A stunning example is Knit Candela in Mexico. The entire shell was made using a knitted fabric that weighed only 55 pounds. Yet, once completed, the finished structure weighed a solid 5 tons, completely freestanding and needing no additional support. Beyond its strength, 3D knitted formwork offers another major advantage: freedom of design. Because there are no rigid molds, builders can easily create complex curves, sweeping waves, and dramatic shapes that would be impossible with traditional construction methods. At this rate, would there be more innovations in the nearest future? Let's see. Floating foundations. Out at sea, a new generation of floating foundations for wind turbines is reshaping how we harvest renewable energy. Experts from the United Kingdom and Japan have developed a groundbreaking way to install offshore wind turbines, and it's changing the future of renewable energy. Traditionally, turbines are mounted on massive bases anchored deep into the ocean floor. But now, engineers have found a smarter approach: floating foundations. These turbines don't float like boats. Instead, they're supported by semi-submersible or fully submersible platforms, similar to the ones used for offshore oil rigs. The design allows the entire turbine structure to stay perfectly upright and stable, even in rough ocean currents. To prevent them from drifting away, these platforms are anchored to the seabed with heavy-duty cables, giving them flexibility without losing their position. But why go through all this effort? The answer lies in the growing demand for clean energy. As the world races toward a greener future, countries need more space to build wind farms. Unfortunately, shallow coastal waters, where turbines are usually installed, are becoming crowded, and not every area has the right conditions for stable foundations. That's where floating designs come in. They make it possible to install turbines in deeper waters, where winds are stronger and more consistent. It's a major leap forward, one that could dramatically increase global wind energy capacity while reducing environmental impact. Does anything even rival this? How fast can China rival this? Keep watching to find out. Concrete that heals itself. In the Netherlands, scientists have developed a new type of self-healing concrete that can repair its own cracks without losing strength or durability. And the secret ingredient? Bacteria. These tiny organisms are mixed right into the concrete. When a crack appears and water seeps in, the bacteria wake up and get to work, producing calcium carbonate, the same natural mineral found in limestone. Over time, this substance fills the crack completely, bonding the broken sides back together as if nothing ever happened. It's a simple yet revolutionary process, a natural repair system built right into the structure itself. The potential benefits are enormous. Self-healing concrete could transform how we maintain infrastructure, especially in places that are hard to monitor or repair, like bridges, tunnels, or remote buildings. It's a smart, sustainable solution that makes our cities not just stronger, but smarter. It also has another major advantage. Self-healing concrete could automatically fix cracks in places that are almost impossible to reach, like the outer walls of skyscrapers. Imagine a building that repairs itself without anyone having to lift a finger. If bacteria are the elements behind these self-healing properties, isn't it necessary to check that there wouldn't be excessive growth in the future? Are there more innovative engineering like this? Let's see. Amphibious foundations. In flood-prone areas like Louisiana, where rising water is a constant worry, builders have come up with a clever solution. Instead of attaching houses to a fixed base, they use foundations that can float. Here's how it works. Under normal conditions, the house rests on solid ground, but when floodwaters rise, the amphibious foundation lifts the entire structure upward, allowing it to float safely above the water. Once the flood recedes, the house gently settles back into place. To keep it from drifting away, the structure is anchored securely to guideposts, so when the water rises or falls, the house moves only vertically. It's a brilliant design that can literally save lives, giving people in flood risk areas a safe place to stay until the danger passes. And if that wasn't impressive enough, the future of construction is taking things even further, with machines that build themselves. Yes, you read that right. We're now in the age of autonomous construction machines. These robots can handle nearly every stage of the building process. Some lay bricks, others pour and level cement, and a few even install windows. There are also self-driving construction vehicles that can pave roads without a human operator in sight. The best part? They don't need breaks, sleep, or lunch hours. They can work around the clock, delivering precise results every time. For construction companies, that means faster projects, fewer errors, and lower costs. And as incredible as that sounds, there's one more invention that takes autonomy and efficiency to a whole new level. What does this mean for the world? Are there more? Keep watching to find out. 3D concrete printing. These massive machines are redefining what it means to build a house. Instead of bricks or manual labor, these printers lay down concrete layer by layer, following a digital blueprint to the letter. Incredibly, a structure that would normally take weeks to build can now rise within days, or even just a few hours. The secret lies in the material itself, a special, quick-drying cement. By the time the printer's nozzle completes a full rotation, The previous layer has already hardened, ready for the next one. It's a seamless, automated process. No human hands guide the printer. Everything is pre-programmed. Once the instructions are uploaded, the machine simply gets to work. No breaks, no fatigue, no errors. The result? Strong, durable, and perfectly precise buildings where every curve and edge is exactly as designed. What do you think about these mind-blowing constructions? Let us know your thoughts in the comments section below. Thank you for watching this video. We hope you found it interesting. Don't forget to like and subscribe. Click the next video shown on your screen to catch up on your favorite celebrity stories. See you there.